All right, guys, here are the answers to the review. This one, number one, none of all of them are numbered, but basically PR is 3. It says what is the area, and it also says that P is the center of the circle. So that means that this is a radius, would mean RT is also 3. So the area of the shaded figure would be the whole area minus this circle. So the whole area would be 6 squared pi, or 36 pi. And then you're going to go ahead and subtract the small circle, which is 3 squared times pi, or 9 pi. You end up with C, which is 27 pi. This one has 5 semicircles, each having the same diameter. So the perimeter of the triangle is 60. We could call each of these X. So that would mean you could see that this is the same distance all the way around. So 5 times X would equal 60, which means that each X is 12. So each one of these semicircles has a diameter of 12, which means the radius of each one is 6. So one of these circles would have an area of 6 squared times pi, or 36 pi. But these are half circles, so each one of these would account for half of this, which is 18 pi. And there are 1, 2, 3, 4, 5 semicircles. So when you multiply by 5, you get 90 pi, which is H. Here, determine the perimeter. It's an isosceles triangle, which means it's a 45, 45, 90. So to find these sides, you would have to do, if this is times root 2, so to go backwards, we would take 14 and divide by root 2. Rationalize the denominator. You'd get 14 root 2 over 2, or, in other words, each one is 7 root 2. So 7 root 2 plus this 7 root 2 is 14 root 2, because if you just add the 7s and leave this as root 2, plus 14, which you cannot combine. So that's answer choice B. Regular hexagon is inscribed in a circle. So the reason why that was important is that the apothem would be this line right here. But a line goes from the center of the circle, and the vertice of the vertex of the hexagon hits right here. So we can know what this is because it says the area is 12 pi, and that's of the circle. So pi r squared equals 12 pi. If I divide both sides by pi, you get r squared equals 12. And then r would equal root 12. Root 12, remember, simplifies into root 4 times root 3. So you get 2 root 3 as your radius. That's this line right here, because that goes from the center to the edge of the circle. Well, that's not the apothem of the hexagon. So right here is 2 root 3. If I bring this triangle out and just enlarge it a little bit, we remember that in a hexagon, this is 60 degrees, this is 30, because this whole triangle would have been an equilateral triangle. So you're given this spot right here, 2 root 3, which is across from the 90. So to go across from the 30, it's going to be divided by 2, which is just root 3. And to go to across from the 60, you would multiply by root 3, which is root 9, or just 3. It says, what is the length of the apothem? Well, the apothem would be right here, which is 3. The area of a triangle with sides 5, 12, and 13 is equal to the area of a rectangle with a width of 10. So first of all, let's find the area. 5, 12, and 13, you normally would not be able to find the area because we don't know the height. But if this is A, and this is B, and this is C, you'll find out that A squared plus B squared actually equals C squared, which means this is a right triangle. And if it's a right triangle, we actually can use the 2 legs as the base and the height. So this triangle has an area of base times height divided by 2, which is 60 divided by 2, which is 30 units squared. And if we know that a rectangle is base times height, and we know it equals 30, and the width, or the height, or the base, is 10, the height of it would have to be 3. Which, I'm sorry. It says, what is the perimeter of the rectangle? We didn't answer that question because if this is 3 and this is 10, that's 10 and that's 3. 10 plus 3 plus 10 plus 3 is 26. City wants to place a garden in its park. Garden will be the shape of an obtuse triangle with the shortest two sides 15 and 25. Remembering that in an obtuse triangle, a squared plus b squared is actually going to be c squared is going to be greater than a squared plus b squared in an obtuse triangle. So if these two sides are 15 and 25, you get 625, and 15 times 15 is 225. So 625 plus 225 would be 850. So c squared has to be greater than 850. If you square up both sides, that would mean c has to be greater than the root 850. If you wanted to leave it in exact form, we would have to simplify this. Root 850 is root 25 times, and then 850 divided by 25. $34. So c would have to be greater than 5 root 34, or if you multiplied what 5 root 34 is, c could be anything greater than that estimated answer. Here you have the first answer is what is the area of triangle ADC, which is this triangle right here. Okay. So we do need to know what the base is. So there's a couple different ways that we can find out what ADC is. I would just take the area of the whole triangle and then subtract this part, and you'd have the area of this one. So if this is 8 and this is a 30, 60, 90, the side across from the 30 is 4, which means this side right here is 4 root 3, which would get us the, well, we don't know the whole area yet. It says that this is a isosceles right triangle. So this would be a 45, 45, 90. So this is 4 root 3, which would mean the BDC would be also 4 root 3 because it says it's an isosceles triangle. So to find the area of the big triangle, I would do 1/2 times 4 root 3 times the base 4 root 3. And you would get, this could become 2. So 8 times 3, which is 24. So the area of this whole triangle is 24. Now the area of this small triangle right here would be 1/2 the base, which is now only 4, times 4 root 3. So you get 8 root 3 as this small triangle's area. So the area of ADC would be 24 minus 8 root 3. And you could get an estimated answer as well. Is BD greater than DC? Or is BD less than DC? So we already know that DC is 4 root 3. So you would just have to know what's greater, 4 or 4 root 3. And obviously, if you multiply by root 3, DC is going to be greater. So it's BD is actually, BD is less than DC. Here it says, what is the area of this right triangle? First of all, you had to find out which one of these was the right angle. And this is your right angle because if you find the slope of this, it would be 4 minus 10, or negative 6, over negative 1 minus 1, which is negative 2. That is a slope of 3. And this line has a slope of 10 minus 6, which is 4, 1 minus 13, which is negative 12, which has a slope of negative 1/3 if you reduce it. And 3 times negative 1/3 gets you a product of negative 1, which tells you that this is your right angle right here. Now to find the area, we would just need to know the distance of this and the distance of this. So I use my distance formula to find this first. So x x minus x, so negative 2 squared, then plus y minus y. So we did negative 1, so we have to start here. 4 minus 10, which is negative 6 squared. So this becomes 4. This becomes 36. So this has a distance of root 40. This would have a distance of 1 minus 13, which would be negative 12 squared, plus 10 minus 6, which is 4 squared. So you get 144 plus 16, which is 160, root 160. So to find our area, we're going to do 1/2 times the base times the height. Can't take half of these because these are in the radical. But when you multiply root 40 times root 160, you get, so it might actually be easier if we simplify root 40 to 4 times 10. So 2 root 10 times, and then 160, I see a 16 in there, would be 16 times 10. So you get 4 root 10. 2 times 4 is 8. Half of 8 is 4. Root 10 times root 10 is 10. So you get an area of 40 units squared. And here, we've actually done one just like this. Quadrilateral form by connecting the midpoint of the base to the midpoint of each leg. And it's an isosceles triangle. You could have done a triangle that looks like this. But I'm going to use an isosceles right triangle, which that way one of my x-coordinate here is still 0. Makes it a little easier. So I'll call that 0a. So if that's A, this one also has to be a length of A. And it says connecting the midpoint of the base. Triangle form a midpoint of the base to the midpoint of each leg. So that would pretty much mean that I would have to find the midpoint here. So instead of calling this A, I'm going to call this 2A, and I'll call this one 2A. So the midpoint over here would be A comma A if you use the midpoint formula. 2A plus 0 divided by 2, 0 plus 2a divided by 2. So if you connect this to this midpoint would be a comma 0. And this midpoint would be 0 comma a. So basically you'd want to prove that this shape right here is a rhombus. You could do this a bunch of different ways. I could find the distance of all 4 sides and show that they're the same distance. You could find that this is a parallelogram by proving opposite sides are either congruent or the opposite sides are both all parallel. And then, the other way you could find that it's a rhombus is if once you prove it's a parallelogram, if you prove that these 2 sides are equal, then it'd be a rhombus. Or if you prove that it's a parallelogram where the diagonals are perpendicular, meaning the slopes of the diagonals equal -1, that would also work.